in sequence.
So really, you could just use this instead of doing.
Yeah, these are all equivalent. These are all more or less equivalent. Okay.
Can you put a separate parentheses to?
Yeah. Do different blocks of it. Well, let's try it out. Yes. All right, so here we're trying to test whether or not these things predict whether or not you're female. So this is the p-value when I compare the null model or the intercept-only model using the reading score. This is the p-value of the model where I look at, I'm now adding math and then finally I add science.
How do you remember those? You say it's only that p-value. Actually, I guess none of them are.
Yeah. So what happens is the first model doesn't do a very good job just using reading score. Then we ask the question, well, how much does math add above and beyond reading score? Well, that gives me a p-value of 0.9, clearly nothing. And then what does science add above and beyond math and reading? Right. So before we talked about the idea of including variables in a sequence, we talked about demographic variables and then perhaps a set of clinical variables for which we thought were interesting and related to the outcome, but we didn't think our policy would affect. And then finally, we had that third set of variables for which we were truly interested. This is one way that we could say, well, what is the effect of each of these things in turn?
So if you find a big difference, like it looks like science adds a lot,
Yep.
you potentially just can you change the order of them and say like it doesn't look like reading, or is that like you have to specify them? And then
It depends on your purpose. If you're trying to build a predictive model, you might then drop the first two. But that third variable is taking into account reading and math. Right? So it's not just science all by itself. I feel like I'm in Africa. And these are going to give me the likelihood ratios. The successive likelihood ratio tests. Okay. So let's talk about what this means for a second. So what does it mean to asymptotically converge? That's geek talk. So this says that as your sample sizes increase, the three of these tests will converge to the same results. You can think of these, the Lagrange multipliers and the Wald test as being approximations to the likelihood ratio test. You can't go wrong if you use a likelihood ratio test. Okay. All right, so many of the post-estimation commands that we used before are also available when you do logistic regression. All right, so that's what this is about. So you can look at things like deviance and residuals and things like that too. Right? Influence observations, all that sort of stuff. Okay. So imagine, for example, you wanted to test to see if the effect of science is the same for math. Are those coefficients the same? You can think of this in terms of when you're doing a regression, right? Let's say that this was like treatment A, treatment B, treatment C, right? Could we compare treatment A versus treatment C, right? This is the same idea here. So what I can do is to see if these coefficients are the same, is I can use the test command. So by saying does science equal math is the same thing as saying is the difference zero. That's what this is saying here. So essentially what they're going to do is that they're going to look at the difference between these two coefficients and see if it's zero. Which is kind of an important thing to know because now you can do those t-tests. If this were a z-squares regression and you wanted to compare means versus groups, for example, you could do that same concept.
So the hypothesis on that is that they are the same?
Yeah. And in here, because the p-value is not below the magical 0.05, we would say, oh, yeah, the effect of science and math is essentially equivalent on your probability of being of having an above average writing score. The other thing we can do is we can test, are they jointly zero? Are they both together zero? Now, it used to be that you could use a Bonferroni here. Okay. They changed the syntax. So if I were to adjust these tests for multiple comparisons, then we would say science is not significant, but math is, taking into account the multiple comparisons. This M test is new in this version. Okay. What else do we want to say? Oh, the other thing that we can do is that we can figure out probabilities for different subgroups or people at different levels of some outcome. Right, so here's what I want to do here. So what I want to do is I want to get a probability of high right, of being in the probability of being in the high writing group at the average levels of reading female and school type by socioeconomic status. Does that make sense? So within each socioeconomic status group, I'm going to figure out the average level of reading, the average femaleness, and the average school type. And then at the average level of these, what's the probability of getting an above average writing score? Does that make sense? So keep holding those other values constant. So we set the average reading score overall was 52.2. A little more than half of the sample was female, and the school type was 1.16. So holding these things at the average, this is the probability of someone in a low economic, socioeconomic status group to get to be to have an above average writing score. Make sense? We could change these values. So we could actually set, well, what is the probability of someone being in the high getting an above average reading score with a reading value of 60 or whatever it is that we wanted. We could set it to be those, whatever level that we wanted. So this becomes the probability of getting an above average writing test score if you're if you're a female and you're in school type 1. Right? So now we can get very specific criteria here. Does that make sense? So instead of it the average thing, now we can say, what is this person's probability? Probabilities and confidence intervals. All right. I'm going to stop here because I have a hard stop at 4 o'clock that I need to get ready for. And we've used the margins command in the past, so it's just sort of more of the same that we've been doing. But the idea was to sort of give you a little idea of, okay, we've been talking about all this crap. How do we actually do it?